Hey everyone, and welcome back. So last time we got our feet wet with variables and data types. Today, we're taking a huge leap forward. We're going to make our programs actually interactive. Yep, we're going to teach our code how to have a real conversation.
I mean, think about it. Pretty much every app you use, right? From a simple calculator to Instagram, it has to talk to you. So let's dive in and figure out how we can build that two-way street between your code and, well, anyone who runs it.
All right, here's the game plan for today. We're going to start with the basics of how programs talk. Then we'll meet Python's special tool for listening. After that, we'll uncover a super common trap. But don't worry, we'll learn the magic trick to fix it, which is called typecasting. And then we'll put it all together and see it in action. Okay, first things first. Before we even touch a line of code, let's just make sure we're on the same page about two super important ideas that let our programs actually be useful to people: input and output.
You know, it's actually a really simple idea, but it's also incredibly powerful. It's a loop, right? Input is just getting data from the user. Think keyboard typing. And output, that's the program showing the results to the user, on the screen. This little cycle, input, process, output, it's basically the heartbeat of any program that actually does something for a person.
So how do we actually get that input? Well, Python makes it super easy for us. It gives us this ready-made tool, a built-in function called, you guessed it, input. Okay, this definition right here is super important. Basically, what input does is it pauses your whole program. It just sits there and waits for the user to type something and hit enter. Once they do, it grabs whatever they typed and gives it back to your code. But here's the kicker, the part you really have to remember. It says it returns it as a string. Not a number, not anything else, always a string. And trust me, that little detail is going to be a big deal in just a minute.
So let's see what this looks like in some actual code. We use the input function. And that little bit of text inside the parentheses, that's our prompt. It's our way of telling the user, hey, this is what I need from you. Then, whatever they type in gets saved into our name variable. And just like that, we can use it like we do here to print out a nice little greeting.
Okay, now we've hit it. The one thing that trips up pretty much every single beginner when they first start with Python. It is a total classic trap. But the good news is, once you see it and you get why it happens, you will never, ever make this mistake again. So check this out. Imagine we use our shiny new input function to ask for someone's age. And let's say the user is cool, they do what we ask, and they type in 25 and hit enter. That value, 25, is now sitting in our age variable. Seems simple, right? But here's the million-dollar question. Yeah, the user typed in something that looks like a number to you and me. But what does Python see? What's the actual data type of that age variable? Is it an integer? And bam, there it is, the trap. The answer is a big fat no. If we actually ask Python, hey, what type of thing is this age variable? It comes back and tells us it's a class string. It's a string. See, input doesn't try to guess. It doesn't care that 2 and 5 look like a number. To play it safe, it just treats everything as plain old text. Okay, so what do you think happens when we try to do math with these so-called numbers? Let's say we get 10 from the user and put it in a variable a. Then we get 20 and put it in b. What happens when we try to print a plus b?
We get 1020, not 30, which is what we wanted. And why? Because a and b are strings. So the plus sign doesn't do math. It does what's called concatenation. It just smushes the two pieces of text together. It literally sticks 10 and 20 side by side.
Okay, so here's the thing. This isn't some random bug. It's predictable. And if it's predictable, that means we can deal with it. We just need a way to tell Python, hey, I know you think this is text, but I need you to treat it like a number. And this process has a fancy name, typecasting.
Here's a good way to think about it. It's like currency exchange. You can't spend US dollars in a shop in France, right? You have to exchange them for euros first. Typecasting is the exact same idea for our data. We're taking the string dollars that input gives us, and we're converting them into integer euros so that Python's math machine can actually use them. And luckily, Python gives us the tools to do this exchange. We have int.slash, which tries to turn something into a whole number. We have float.slash, which is for numbers with decimal points. And, just so you know, str.slash does the opposite. It can turn a number back into a string if you ever need to.
Okay, now look at this. This is the right way to do it. It's a small change, but it makes all the difference. See what's happening here? We're wrapping our input call directly inside the int function. We're kind of nesting them. This forces Python to convert the string 10 into the integer 10 before it even gets stored in the variable a. So now when we say a plus b, Python sees two actual numbers, does proper math, and boom, we get 30, exactly what we expected.
So let's break it down into a super simple, foolproof process you can use every time. Step 1, you grab the data from the user with input. Step 2, you immediately convert it to the type you need, usually with int or float. And step 3, now you're good to go. You can use your variable in your code, confident that it's the right type.
All right, theory's great, but let's see this stuff in action. We're going to look at a couple of small but really practical examples where this whole thing just clicks.
Okay, here's a perfect one. We want to calculate the year someone was born. We ask for their age, and we absolutely 100% have to convert it to an integer with int cut. And why is that? Because look at the next line. We're doing subtraction. You literally can't subtract the word 25 from the number 2025. Python would just throw an error and crash. But since we converted it first, the math works beautifully.
But, and this is important, you don't always have to convert. Take this example. We ask for a city. Well, a city name is text, right? We want it to be a string. We're not going to be multiplying London by Paris. We just want to print it out. So in this case, leaving it as a string is exactly what we want to do.
Okay, let's do a super quick wrap-up of the big takeaways here. Number 1, input is how you talk to your user. Number 2, and this is the big one, input always gives you back a string, no exceptions. And number 3, if you want to do math, you have to convert that string to a number first, using int or float. Seriously, if you can get this input, convert, use pattern down, you've just taken a massive step in your Python journey.
And that's a wrap for this one. You now have one of the most fundamental powers in all of programming. You can make your code listen. It can respond. You can ask for a name, a number, a city, and then do something with that information. This opens up a door to so many possibilities. So I'll leave you with this question. Now that your programs can listen, what are you going to build first?